This is our second lesson. So I hope that by this time you already watched your first video and finished your homework, okay? So for today's lesson, we are focusing on the third learning outcome, which is how to find the area either under a curve or like between a curve and a line or between a curve and a curve. So before we move on for that session, right, so I'm going to do some recap on the definite integration. I think for like yesterday lesson, what I was doing is like mainly focusing on the example part because that's the thing that you already learned in IG. So I wish to do some recap on the more technical part, and hopefully this can help us to answer the area question later. Okay, so just a very quick one. These are the few formula that we actually already go through yesterday. So when we talk about definite integration, right, so if you still remember, meaning that we have an integration with a limit, like for this case, like from a to b fx with respect to dx. Okay, so when we have this definite integration, what happens is we will differentiate the function inside. So for this case, maybe we let the function after integration to become capital Fx. Then after that, you write down your upper limit and lower limit, which is b and a. So you will be substituting the upper limit first, then minus the lower limit. So this is basically your formula for definite integration. Okay, so you have these four formula, right? So I'm going to apply it together in the definite integration. Oh, by the way, why definite integration we do not need to do x? So the idea is you can imagine after fx, when you integrate, right, you get a c. So when you substitute b, you left your answer in c. Then after that, when you substitute a, you have a c also. So that's why when c minus c, you get 0. So that's why when you do definite integration, you do not need to put an c there. Okay, so we are looking at like this formula. Okay, so yesterday we said that if there is a kfx, then what we can do is we can bring out the constant, and after that you do normal integration for the function part, then after that you only multiply. So it's the same thing applies for definite integration. So if you have a function fx where you integrate and your limit is from a to b and is a kfx, so it's the same thing. You can bring out your k, then after that b a fx dx. Okay, so it's going to be the same thing. Then after that, if you have a function plus or minus the other function, so meaning like in this case, b a fx plus minus gx dx is going to be equals to integrate fx from a to b dx plus or minus ba gx fx. Okay, is that alright? And after that, one more, which is, let's say if I have integrate fx with respect to dx from a to b, right, it's basically the same thing with, so you imagine ba, meaning that I will be doing integration, then substitute b, then minus the function with substitution a. So imagine if, let's say, I try to change these two, so meaning that from a to b, I try to change it to from b to a. So what happened is, if let's say fb equals to 3, so when then fa equals to 1, so when 3 minus 1, you get 2. So what happened if you use 1 minus 3? So you get negative 2. So meaning for the integration from a to b for fx is going to be the same with negative from b to a fx dx. Okay, we will be looking at this formula in the application of area later. Okay, and the last one will be this. So let's say if I have CA. Okay, so this is going to be the same thing like you can imagine. So if I have A to C, so in the middle I have A. So is it the same if I say A to C and from A to B and then from B to C? So it's exactly the same thing. So meaning for this limit, we can always write it in the way that from A to B, then after that from B to C. Okay, so what you can realize is integrate fx dx, so from A to B plus from B to C is exactly the same answer with from A to C. So later we'll be using this field formula or this field concept that we get and apply into the area under a curve. Okay, so now we'll be looking at the thing that we're going to learn today, which is area under a curve. So I'm going to explain the two scenarios at one shot, so you can try to identify the difference between these two, and I hope that you can get the idea like what is the situation that you should take scenario 1 and what is the situation for scenario 2. Okay, so for scenario 1 is basically area enclosed by the curve y equals to fx and then x-axis and lines x equals to a and x equals to b. So basically meaning that I have a curve, okay, and then this curve is y equals to fx, and then this is my x-axis, and I have line x equals to a and x equals to b. So maybe like here, this is a and this is b, and I'm finding the area here. So area enclosed by the curve, the x-axis, the line x equals to a and x equals to b. So normally what is the way that can help you to remember this better is that when you have this case, right, so your area, which is A, will be equals to, so you see this one is between the curve and the x-axis, so you remember you will write with respect to x. And then what is inside, when you write dx, then you will be putting y. Okay, then your limit is basically what is the limit along your x-axis, which is from A to B. So meaning A and then B. So this is how you write your equation. So remember, for your area that is above your x-axis, so which is all your y will be positive, then your area, or like the integral that you can find out of this integration, will be greater than 0. But then if you have a curve, like for example in this case like this, like you are finding this area, so you can see the y here is going to be negative. So if it's below x-axis, then you are going to get an integral which is smaller than 0, so which is a negative. But then because of all the area must be positive, then we will state that a is greater than 0, so you should change your answer to be a positive answer, meaning like if you get a integral as -3, then after that you will write your area as a positive. So I will try to write this in like a summary form. So meaning if you have something, a graph like this, so if you need to find this area and you need to find this area, so this area will give you a positive answer and this area will give you a negative answer. Okay, so that's the idea. So this is the first case, which is enclosed by the curve, the x-axis, and the limit along the x-axis, which is from A to B. The first case. Okay, so the second case, sorry, I think I did something wrong here. Let me change it first. Should be x equals to gy. Okay, so this is area enclosed by curve x equals to gy, x-axis, and the line y equals to a and y equals to b. So you don't need to matter on this first. So this is basically like if you have y equals to x plus 1, then when you change it to x, then become x equals to y minus 1. Okay, so don't worry about this. Okay, so basically you have another curve, then I'll try to draw it here. So maybe you have a curve like this. So the name of this curve is like x equals to gy. So the area will be enclosed by the curve, the y-axis, and then the line y equals to a and y equals to b. So it's like here a, and then here b. So this is the shaded region. Okay, so for this case you will have area a, which is going to be the same. So you can try to write out this one first. So this is like for the curve and the x-axis, so you will put dy. So as you put dy here, then what are you going to write in front? You write x. So this is x-axis, so you write dx and you put y. This is y-axis, so you put dy and you put x. So what is the limit for your y-axis? Is going to be a to b. So a, b. Okay, so this is how you get this area. So for this case, for that one is like above x-axis or below x-axis. So this one will be like at your right of your y-axis or at the left of your right as x-axis. So meaning if at the right of your y-axis, which means all your x here will be positive, right? So you will be getting your integral as a positive answer. But then if you have something on your left, so meaning like this, okay, so which is at the left of your y-axis, and you will be getting integral as negative. Okay, so same thing, I'll try to do a summary here. So meaning that if you have something like this, so this part is going to give you a positive, this part will be giving you a negative. Okay, so basically for every question you need to identify yourself whether it's like an area enclosed by the curve and the x-axis or y-axis. So if you have x-axis, that means that you need to get your limit like for along the x-axis, meaning like from a to b. So if you say that the area is enclosed by the curve and the y-axis, then you need to find what is the limit like for along your y-axis, which is like for this case a to b. Okay, I'll be putting this paper like all along here. Then I think that it will be useful if you try to write down before you look at the other example. Okay, so later we'll be doing some example together. Okay, so we are looking at some few examples. So for this few example, you're just going to write down the expression whether it's this one and learn to, or this one, and learn to identify whether it's a positive one or a negative one. So because I believe that you should be able to solve the definite integration part, so for the calculation part we will be trying to ignore it first for now. Okay, so look at this example. So this is exactly a graph, a curve. So the area is actually bounded by the curve, the x-axis, and also the limit from the 0 and 3. So is that going to be the first case or the second case? Okay, so you can see is this graph is going to be, so you imagine, right? So this is a curve. So okay, the answer for this one is like the curve and the x-axis. So imagine if it's a curve and a y-axis, so what happened is it will be going to that way. So meaning like if this is the curve, then bounded with y-axis, then it will be outside here instead of inside. So if it's this case, right, then it's going to be like cut it off here and you only bounded here. So for this answer, it will be area equals to from 0 to 3. So this is bounded with an curve and your x-axis, so dx, and when you write dx, is going to be y inside. Okay, so this one is x-axis, so above x-axis you are going to get an answer that is positive. Okay, so let's look at the second one. Okay, so now it's going to be the exactly same graph. It's just that the place that we trying to shade is different. Okay, so the limit here is a new one, -1 to 0. So this is actually A equals to -1 to 0. Same thing, this is bounded with x-axis. So y. So is this going to be a negative? No. So although this is on the left side of your graph, but then when we talk about first case, right, the one that positive is actually above x-axis and below x-axis only is negative. So this is still positive. Okay, so look at the third example. So now we combine. Okay, so since that these two graph gives you a positive, so when you combine it, do you need to write it in 2? So you do not need to do it in separate. So basically A will be equals to from -1 to 3. Okay, y dx. So this is going to be positive also. Okay, so look at the fourth. Okay, so this is basically a curve and x-axis also. The limit is going to be -1 to 4. So when you are looking at curve and x-axis, so the limit that you are reading must be from x-axis also. So you look at like -1 to 4 like that. So area will be equals to from -1 to 4. So again, this is between a curve and x-axis, so dx, and we're going to use y. Okay, so now is this a positive or negative one? Yeah, so when you do this part, you are going to get a negative, then later on you are going to do modulus and you should get your answer. Okay, so for the last question here, so yeah, if you want to find the total area for this, how you should be doing that? So you can imagine, right, if you combine them together, you will get a positive for this graph and you will get a negative. So when you have a big negative graph minus of the positive graph, are you going to get the total area? Because total area, we are saying that you need to use this to plus this one, and both must be in positive, so that's why we cannot combine them, so you must do it separately. So meaning that in this case, we are going to do area equals to -1 to 3. So same thing, this is bounded with the curve and the x-axis also. So y dx, and then plus 3 to 5 y dx. Okay, so this is going to be a negative answer, this is going to be a positive answer, and later you are going to use modulus to change it into positive. Okay, so I hope that you can like get the idea. Now we try to look at the y-axis part. Okay, so let's say, yeah, can you try to see the difference? You try to jot down, so I hope that you can get the difference. Okay, so for the first one, so a curve and y-axis, so the limit is like from 1 to 5. So integrate limit 1 to 5. So this is curve and y-axis, so that's why we try to put dy and then x. Okay, so this one, oh sorry, so this one is at your right hand side of your graph, so this is going to be positive. Okay, so the second one, so now you have graph like above the x-axis and below the above the x-axis and below the x-axis. Are you going to do like separately? Yeah, so in this case you do not need to do so because it's the curve and the y-axis. So what happened here is when we look at this case, right, only at the left hand side you will get a negative answer, so you do not need to separate it. So meaning for this case it's going to be -6 to 5 x dy, and then still positive because it's on your right hand side. Okay, now look at this one. Yeah, so this is the case where we have a left hand side, so we still do the same thing. So the limit is from 0 to 5. Okay, x, so bounded with y-axis, and then it's going to be negative because it's on our left hand side of the graph. Okay, so this one you need to find the total area. Yeah, so this is the same case with what we have here. So when we do dx, right, then we will be doing like one above and one below, and we try to get the answer. So for this case, we are doing separately because not because of one above and one below, but because of one is at the left hand side and one is at the right hand side. So let's settle this part. So it's going to be 0 to 5, which is exactly the same thing like this. Okay, then later you need to plus another one from negative 4 to 0, and then x dy. Okay, so for this one you are going to get a negative answer, this one you are going to get a positive answer, then after that you change this into positive and get your answer. Okay, so these two. So we are going to look at something special like for this one. If you have an area like this, how are we going to write it? Okay, so for this case, right, because they don't have any specific limit, meaning like they don't draw a vertical line or a horizontal line to state the limit, so it's basically like 4, 8. So for this question, actually you can use two ways to find it. So maybe let's see like with respect to your x-axis first. So when we look at x-axis, right, meaning that our limit it should be going to like this way because x-axis. Okay, so let's do one with the x and the other one with the y. Okay, so when we do the x, then we are looking at along the x-axis, what is the limit? So, oh, I'm sorry, this is going to be negative 4. Okay, so let's say along the x-axis, so it's going to be negative 4 to 0. So that's why negative 4 to 0. And since this is along x-axis, so we are going to put y. Okay, so now this is along your y-axis, is from 0 to 8. So we are going to put x. Okay, so if you are doing for the first case, right, where integrate y with respect to x for a limit from negative 4 to 0, are you getting a positive or negative? So this one we are looking at x-axis, so above x-axis you are still getting a positive. But for this case, when you are doing the y-axis part, is on your left hand side, so you are going to get negative. So basically your answer, the value that you get will be the same, it's just that the sign will be different, depends on which method that you are using. Okay, so for this question, can you tell me if I want to find A, then what is my answer? Okay, so it's going to be the same curve, but the area that shaded here is different. Okay, so let's say if I want to find A. Okay, so it will be, so you can see this is a curve with x-axis and the limit like goes along your x-axis from y to z. So that's why from y to z, so along your x-axis, so that's why we use y. Okay, so if you want to find area for B here, so it's going to be the curve and the x-axis, so the limit is along your y-axis. So that's why from x to w, it's going to be x and then dy. Okay, I hope you can get the difference from this example here, and later we are going to do the question where you need to finish everything, include calculation. Okay, now we'll be looking at 4 examples and we're doing it from the beginning to the end. Okay, so find the area of the shaded region. So for this one, is obviously it's going to be a curve and the x-axis, because like your limit is actually set along the x-axis. So that's why you know that you need to write integrate y then dx. Okay, so in this case, right, so you are having two separate region, then you need to check, so if this is along the x-axis, is the two separate area going to give you different answer if in different sign or not. So like this is above the x-axis, so you see above x-axis, along the x-axis it will give you positive, but this is below the x-axis, so it will give you a negative answer. So we will need to solve this question separately. Okay, so you have area the first one and the area second one. Okay, so let's say we have area the first one maybe. Okay, so this is, we assign it to be area 1, this is area 2. Okay, So let's find area 1 first. So differentiate. Okay, so your limit from 0 to 3. Okay, y dx. Okay, because it's along x-axis. So equals to, okay, then you putting your equation inside. So maybe we try to expand it first. So x times x, you have x squared, then x cubed, then minus 8x squared, and then plus 15x. Okay, dx. Now you can integrate them. 1 over 3x, 4. 1 over 4x4 minus 8 over 3x cubed plus 15 over 2x squared. 30. Okay, then you do definite integral. Yeah, okay. Please try to take a paper and a pen and do together. If not, you're going to be like watching that. After that, you might not learn anything. So yeah, max, you need to do practice. Okay, so 0, when you substitute 0, you get exactly 0. So you just minus 0. Okay, let's continue. Equals to. So you can use your calculator and try to get it, and you should be able to get an answer that gives you 15 3/4. Okay, so you check it yourself. Then after that, let's continue with A2. So for area number 2, so you have a limit from 3 to 5. Okay, y dx also 5, 3. So it's going to be the same equation, so which you can just copy from the above. Same thing for the integration. Okay, then you substitute 5 and 3. Yeah, I'll skip this step. I hope that you know how to do this, and you try to check your answer, and you should be getting negative 5 1/3. Okay, and then after that, you see that because this is below the curve, right, so that's why you are getting a negative answer. So what we will need to do is you need to state that, so area must be greater than 0. So that's why your A2 is actually equals to 5 1/3. Then after that, your total area should be equals to 15 3/4 plus 5 1/3, which gives you 21 1/12. Okay, so you must be very mindful. So if you didn't do it separately, right, your answer that you will be getting will be like this one, plus this one, it become minus already. Yeah, okay, so your answer should be a positive plus a positive area and get to your last answer. Okay, so let's look at the next example. Okay, let's look at the second example here. Okay, so let's look at the area first. So this is your shaded region, and it is enclosed by the curve, the y-axis, and the line y equals to -1 and y equals to 1. So for this case, it's basically the case 2, where we need to use differentiate with respect, differentiate x equation, then with respect to y. Okay, so now let's try to write down, and you need to identify that whether you need to do it separately or together. So since this is case 2, right, so case 2 we only have a negative when the graph is on your left hand side, so that's why we can combine this and do it at one time. So meaning that this is going to be from the limit -1 to 1, okay, and then dy. So as you put a dy here, you need to put x inside. Is that okay? So why do we put y? Because it's enclosed by the curve and the y-axis. So as you put dy, then you will need to put x. So now you will need to think of what is the equation that making your x as your object that you can substitute into this question. Okay, so the question given y equals to positive and negative square root x minus 1. So we need to change this for x as the object. So when we move it here, then you will get y square equals to x minus 1. So x will be basically equals to y square plus 1. So this is our equation for x in terms of y. So integrate 1 negative 1 y square plus 1 dy. Okay, so it will be equals to, then we can start to integrate y square over 3 plus y. So normally for this case, you will realize whether you do it correct or not when you reach this stage, because when you write dy, then your equation must be in terms of y. So if you get something like x here, then you know there's something wrong. Okay, so upper limit, lower limit. Okay, then you do it normal. So 1 power 3 divided by 3 plus 1, and then minus negative 1 power 3 divided by 3 negative 1. Okay, so you should be able to get a 4 over 3 here, and minus negative 4 over 3 also, and you will get an answer 8 over 3. Alright, so that's it for this question. So let's move on for the next one. Okay, so if you have this case, so for this one you can see that it's actually bounded by the curve. The line y equals to -8, the line y equals to 1, and is enclosed with the y-axis also. So for this case, right, so the question is whether you need to do it separately or not. So for this one, yeah, because it's on your left hand side and this area will give you a negative value, so you need to do it separately. So this is basically A1, then maybe this one we put it as A2. So for you to find the total area, you need to get A1 then plus A2. So we start with A1 first. So basically for this one, your limit will be from 0 to 1. Okay, so this is enclosed with the y-axis here, so dy and x. So equals to, so since y equals to x power 3, right, if we change the x to be the subject, then it will be y 1 over 3. Okay, so shape 1 0 y 1 over 3 dy. Then you start to do integration, which gives you 3 over 4 y 4 over 3 and 1 0. So when you substitute 1 here, you get 1, and you should be able to get 3 over 4, then minus 0, which gives you the exactly same answer. Then let's move on to A2. Okay, the limit will be -8 to 0 x dy equals to 0 -8 y 1 over 3 dy. Then the same thing. Okay, so for this case, try not to ignore the 0, try to write 0, because when you didn't write it, then you forgot that it's actually minus, that you need to minus off the answer that you get here. So 3 over 4, -8, 4 over 3. So for this case, you will be getting -2, then positive 16, then 4, 4, 12, and you should be able to get -12. Okay, so since area is always positive, so that's why your A2 should be 12. So total area will be equals to 3 over 4 plus 12, which gives you 12, 3 over 4. Okay, that's all for number C. Okay, so move on for D. Okay, example D. So Alright, so this example obviously you can see, so this is area bounded by the curve, the x-axis here. So okay, you can realize that this is not like bounded with your x-axis or y-axis, because in this case this is a quadratic curve which is a symmetric curve. Then we are going to look at half. So you can see when we look at this half, right, it's going to be this curve, then after that bounded with x-axis, and the range, the limit from like the 1 here to 3. So when you try to cover the other half, it's going to be the same like the curve, and then bounded with the y-axis and the line y equals to -1 and y equals to 3. So that's why we need to do it separately, because this is like towards your x-axis, along your x-axis, and both area will give you one negative and one positive. So when you are combine them together, then you will get a 0 answer and so on. So that's why we need to do it like in 2. So instead of doing a1, a2, you can realize this is a quadratic graph, and this is basically the minimum point, which is 0 and -1 here. So for this case, right, you instead of doing like a1, a2, what you can try to do is we try to do it as 1, then after that, after we get the answer, then we use the answer to multiply 2, because this area and this area should be the same. Okay, so let's try to do this part. So A will be equals to, so 2 times, then we start to do the area, the limit will be from -1 to 3. Okay, -1 to 3. So for this part, so bounded with the curve and the y-axis, so it's going to be dy, and after that inside is going to be x. So the same thing, we will need an equation for x. So y equals to x squared minus 1. So y plus 1 equals to x squared, and x will be equals to plus positive negative y plus 1. And what you can realize here is the negative, of course, is for the negative x here, and the positive will be for the positive. So of course, if you want to find this side and multiply by 2, then you use the negative equation. If you want to find this point, this area here, and you multiply by 2, then you use the positive one. But for this one, you will get a negative area, then you need to change it to positive now. But the idea is the same, you still get the exactly same value. So equals to, then 2 times, I'll be using the positive side because that would be an easier option. Okay, so y plus 1 over 2. I'm sorry, we didn't start it yet. So 3 -1 and dy. So equals to 2 times, then I started to do my integration. So remember, power plus 1 divide by your power. So you will get 2 over 3, and then y plus 1, 3 over 2. So your a here is 1, so divide by 1 is totally fine if you don't write it. And 3 -1. So it will be equals to 2 times. So substitute 3. So you will get 2, 3, and then 3 plus 1 power 3 over 2. So when you sub -1, you get 0. So it's basically -0, and equals to 2 times. So for this case, you will be getting an answer that is 4 to the power of 3 over 2, then times 2 divided by 3, which gives you 16 over 3. So times 2, you will get 32 over 3, which is 10, then 2 over 3. Okay, that is the part for the last example for this point. Okay, now we'll be looking at the next part, which is an area enclosed by a curve and a line, or enclosed by a curve and a curve is going to be the same. So let's look at this picture. Okay, so now let's say you have these two lines, one straight line and one curve. So if we try to put the curve as y2 maybe, so y2 equals to your fx. Okay, maybe we try to put the straight line as y1 equals to your gx. So now this area is basically an area that is bounded by a straight line and a curve. Okay, So how do we find this? So you can see this is the straight line, right? Then I try to put this is the y1 graph. So when I find the area of, let's say this is, let's do this AB, okay? So when I take the straight line out separately, I'll be doing AB also. So what happens is if I want to find this area, I will be actually doing from A to B, and then I will differentiate y1 then with respect to dx, correct? This is how I get this area. So the same thing if I continue to the third picture. So this is my y2, which is basically the curve here. So when I want to find this area, then what I'll be doing is I'll be doing integrate A to B also, then y2 with respect to dx. So you can see this area is basically the area under this straight line minus the area under this curve. So I will be getting this answer. So if we combine these two together, right, what we'll be getting is, you remember there's one formula when we did recap just now, is that the one that telling us that if you have something fx plus or subtract gx, you can actually separate it. So it's going to be the reverse. So meaning that if I can do this from this, I can also do this from the second part. So now we are going to like combine them together, which you see this is they have the same limit from A to B, from A to B. So meaning I can always combine them to become from A to B and then y1 minus y2, which is basically just now like your fx plus or minus your gx, the same thing. So dx. Okay, so this is how we are going to solve the other question later. Okay, so now look at the first example. So I'll be putting this here. Oops. Okay. Alright, so example 1. So we need to find the area of the shaded region in this question. So let's look at this. So you have this picture. So let's try to look at this one. So basically what happened here is, you see you have a straight line and have a curve. Then after that, when you want to find the area, it's basically the area under this straight line is going to minus the area under this curve, and this is how you get the shaded region. So now let's see. Okay, so how you want to identify your y1, y2? So when you look at your area of shaded region, right, the line that is above the other line, that will be your y1. So like in this case, the straight line is above the curve. So meaning your straight line will be your y1. So your curve will be your y2. Okay, so when you put them together, then it will be, let's look at the straight line first. Okay, so how do you find the area for the area under the straight line? So it's going to be like this. So what is the limit here? So it's your x value. So -3 and 1. So meaning if I want to find the area under this straight line, then it will be from -3 to 1 and then y dx. Okay, so this is your y1 lah maybe. Okay, then minus 1, -3, then your y2 dx. Okay, this is the area under the curve. Okay, so now let's try to substitute your y1, y2. So your y1 is basically 5 minus 2x dx. So if you can do this straight away, for this part you don't need to write, it's totally fine. Minus 1, -3, and then x squared dx. So equals to, so you remember just now we said that if you have this, you have an equation that actually is the same limit, then you can combine them together. So this is y, -3 and 1, -3 and 1, then we can combine them together. So meaning I can actually write 1, -3, 5 minus 2x, and then minus x squared. Okay, then dx will be equals to, then now only I start to do my integration. So instead of integrate two equation, then now I will only need to differentiate one equation. So 5x minus x squared minus 1 over 3 x cubed 1 negative 3. So equals to, substitute 1, substitute negative 3, okay, and you will be getting your answer 5 over 3 minus negative 9, and they'll bring you to your last answer 10, 2 over 3. Okay, you can understand? It's basically look at the region that you want to find. So the line that is above your right will x y1, then this will be your y2, then you minus and you straight away continue to do it. Okay, so let's look at the next question. Okay, so it's going to be the same. So this is an area that is enclosed by a curve and a line also, but for this one it's not fully by a curve and a line, but with a limited range. So maybe we can find the range first. So for this case it's going to be 0, and what is the number here? So this is 2, 1, so basically it's 2. So how are we going to find that? So it's the same thing, identify your y1, y2, so which line is above which line. So for this one, when you look at this area, it's going to be the straight line is above the curve also. So your straight line will be y1, your curve will be your y2. So differentiate from 0 to 2. So y1 is your straight line. So your straight line equation, 3 minus x dx minus, same limit, the curve under the area under the curve, so x minus 1 square dx. So now 0 to 2, 0 to 2, so now we can combine them together. 2, 0, 3 minus x minus, okay, so I expand this, x square minus minus become plus, and then is plus, then minus become minus 1 dx. Okay, then you simplify your equation first. So negative x square plus x, and then plus 2 dx. Okay, then now you can start to do differentiation. Oh, sorry, integration. Negative 1 over 3 x power 3 plus 1 over 2 x square plus 2x. So 2, 0. Then substitute. Negative 1 over 3, 2, 3 plus 1 over 2, 2 power 2 plus 2, 2. So minus 0, just basically minus 0. Okay? So equals 2, then you will get your answer 3, 1 over 3. So that's all for B. Okay, so let's move on for C. You see that? Okay, so move on for C. Okay, so this question. So this will be a little bit tricky. So we try to prove that what do we need? Is it the same thing that what we identify? Okay, so the tricky part here is that you remember, so as we do along our x-axis, which is when we do dx, right? The area that actually under your x-axis, so just now, the area that actually below your x-axis will be getting a negative area. So for this case, you have a negative area here. Can we use that method to do, or we need to separate that into two? So now we try to identify it. Okay, so let's say, oops, are you still, I'm sorry. Okay, so let's say, let's try to do this separately first. So we use another paper. Okay, now look at this question. Normally, when we want to find, right? Okay, you see, for this question, if you want to do it separately, then what are the way that separately you will do it? Okay, so I think we can draw this first. You can have 1 here, and you have 10 here. Okay, so let's start with the area of the straight line first. So basically for this one, for a straight line, it's going to be 1, 10, and then your straight line is, maybe we put y1 because it's above the curve, right? So y1 then dx. Okay, that is what under the curve. Then what do you have? You need to minus this, and maybe you need to plus this, correct? Because the area here is just going to be this part. Okay, so now you will need to minus this and minus that. Okay, so what is the value for this place and this place? Okay, maybe I'll just put an A and B. So I don't know what is that. Okay, so when I put A and B, right, so meaning I'll need to minus off from 1 to A. And then which is my y2 dx. Okay, you are following me, right? So meaning minus off this area. So meaning like here, then I minus off here. Okay, so now I do the same thing for this side. So I need to minus off from B to 10. Then y2. Okay? Okay, now what I need to do is I want to find this area also. Then I need to plus the area here. So how do I find the area here? I will need to use my y2 also, but I will need to plus it, correct? I will need to plus the area here. But the idea is the area under here, for what I get, I will get a negative value. So I will have a modulus here. So meaning anything negative, I will negative the answer and try to make it positive. So now let's look at this one. What do I have? I have A to B. So A to B, y2 dx. Okay, can you see that? Okay, so this is plus. So now if you write plus and you have a negative answer, then later you are going to minus. So that's why this is a negative value, and you have a modulus here, which is no matter what happened inside that you're going to get a negative, you try to change it positive. So we can actually write minus, because minus only give you positive, which is you want to plus this area. So now what you can realize is this going to be minus, 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 and when I combine them together, right? So you can see 1a y2 dx, and then I put this first. So because minus, then I put them into a bracket, so this can become plus. So ba y2 dx, and then plus the last thing here, b10 y2 dx. So what you can realize here is when I combine here, right, I can actually this is 1 to A, then A to B, then B to 10, and I can always combine them into 1 to 10 y2 dx. Okay, so from what we have gotten here, you can realize that actually if you want to do minus this two part and you plus this part, it's going to be the same thing as you only do your normal y1 minus y2. So in this case, when you do area enclosed by a curve and a line, it doesn't matter that whether your line and your curve is above your x-axis or below your x-axis, you're still going to get the same answer. So you do not need to separate the area and do like A1 and A2. You can do it straight away, y1 minus y2. So for this case, meaning that we do not need to do our A and B here. So we will do it like normal, like how we solved just now. So this is 1 to 10. Okay, and then y1, which is our straight line. I'll straight away right here, 4x dx, and then minus, same thing, 1 to 10, and then this is for the curve, which is below your straight line. So x squared minus 7x plus 10 dx. Then I'll solve it like just like how I solved just now. So equals to 10, 1. So negative x squared, 4x plus, so 11x minus 10 dx. So it will be equals to negative 1 over 3x cubed plus 11 over 2x cubed, sorry, x squared minus 10x, and then 10 and 1. So can you try to do this by your own? So you'll be substituting your number and you will be getting 350 over 3 minus negative 26 over 6, and you will be getting 1211 over 2. Okay, so you can try it out yourself. So basically you just remember that it's no difference whether your curve or your straight line is above the x-axis or below the x-axis. As long as you have area bounded by a curve and a line, you just use y1 to minus y2. Okay, we'll look at another example, the last example, that is the area enclosed by a curve and a curve. Okay, so in this case, the question didn't give you what is the limit, or they didn't give you the intersection point. So you need to find it out yourself. So you have this curve, which is y equals to 16 plus 4x minus 2x squared, and you have the other curve y equals to x squared minus 2x minus 8. So the intersection point, either you can use like y equals to 0 to get your answer, or if not, you can find the intersection point. So basically this 2 point is the intersection point, so we can solve it. 16 plus 4x minus 2x squared equals to x squared minus 2x minus 8. So 3x squared minus 6x, move this over, move this over, move this over, minus 24 equals to 0, which gives you x squared minus 2x minus 8 equals to 0, and then x 8, so plus 2x minus 4 equals to 0, which your x is negative 2 and 4. So which means the intersection point here will be negative 2 and 4. So now you can do it like normally. So again, remember there's no difference whether you have a positive or a negative area for the area like this. So you can straight away. So for this region, this line is above this line, so this will be your y1. So your y1 will be 16 plus 4x minus 2x squared. Your limit is negative 2 to 4 dx minus 4 negative 2. So your second line here, x squared minus 2x minus 8 dx. Okay, and then equals to, so now you can combine them. So minus, so you will get negative 3x squared and then plus 6x plus 24 dx. Then you can start to do integration. So negative x squared plus 3x squared plus 24x. Okay, then upper limit, lower limit. So continue by yourself and you should be able to get 80 minus negative 28 equals to 108. Okay, so that's it for the area enclosed by a curve and a line. And the last part, we'll be looking at three more challenging questions for this part, and we'll end for this session. Okay, so this is the three last questions before we end this lesson. So you can try to copy down the question first, so if you can answer, then you can try to answer yourself, then only check your answer. So after you try, if you think that you cannot do that, then you only listen to explanation, okay? Alright, so A, you need to write down the coordinate where the curve crosses the x-axis. So this is your curve, so the point that crosses x-axis, so basically is your x-intercept, which your y equals to 0. So A, okay, when y equals to 0, meaning x squared minus kx equals to 0, which gives you x, then x minus k equals to 0, where x equals to 0 and k. So the coordinate is basically 0, 0 and k 0. Okay, so this is the point lah, 0 and k. Okay, so after that, what we are trying to do is, oh, I'm sorry, I think this question is without this k. Okay, no wonder. Okay, so 0, 0 and k 0. Okay, so B, given the area below the x-axis is equal to the area above the x-axis, meaning the area here and the area here is going to be the same, and you need to get k. Okay, so meaning what is the difference between these two areas? So it's going to be the same in terms of value, but don't forget this is the area below the x-axis and this is the area above the x-axis. So when we are trying to do that, then you remember to put a negative sign. So meaning if for this case, right, we try to make our area positive, so for this answer you will need to times with a negative. So meaning negative, your limit is from 0 to k, so 0 k. So for this curve, okay, dx is going to be the same. I'm sorry, I should write it in a, yeah, okay, but you can understand it's a equation, is not an expression. Okay, so will be equals to the area from k to 3, x squared plus kx dx. So you can understand why we are putting a negative, because this one you get a negative answer and we need to negative the answer for us to get a positive area. So for this part it's already positive, so you do not need to do that part. Okay, then after that we can try to integrate this. So negative, just put it outside. So x cubed divided by 3 plus k over 2 x squared. Then k0 will be equals to x 3 over 3 plus k over 2 x2 3 and k. Okay, then after that you can continue to solve it. Negative, so substitute k inside and you will be getting k cubed over 3, and then this is k cubed also. When you times k you get k cubed also, divide by 2. Okay, then 0, when you substitute 0, basically you are getting 0, so we can ignore that part. So equals to, so when you substitute 3 cubed over 3 plus k over 2 3 2, and then minus for the k cubed over 3 plus k cubed over 2. Okay, so when this one bring over here, then you will eliminate each other and you are getting your last part should be 0 equals to 9 minus 9k over 2. So 9k over 2 equals to 9, so k will be equals to 2. Okay, so bring 2 over 18, 18 divided by 2, you get 18 divided by 9, then you get 2, so x equals to 2. Okay, so that is example number 1. So let's move on to example number 2. So same thing, you can try to copy down the question. If you can answer, then try to answer yourself first before you look at the question, before you look at the answer, sorry. Okay, so example 2. So given that for integral y with respect to x from 1 to 6 is 30, then find the value of 4 to 12 when you differentiate, when you integrate y with respect to, when you differentiate x with respect to y. Okay, so now let's identify what the question tells us first. So you have, when you integrate y with respect to x from limit 1 to 6 gives you 30. So where is the 30 in your graph? Okay, so this is your curve, right? And then 1 to 6. So dx basically is like between your curve and the x-axis itself. So what we can try to do is we try to do this. So actually you can realize that for here, it is 1, then this is 6. So it's exactly fulfill what the question tells us, that from 1 to 6, and then the curve and the x-axis. So meaning that the area here is actually equals to 30. Okay, so what the question want to find? The question want to find for 4 to 12, and then for x with respect to y. So meaning that it's your y-axis. So you see the y coordinate here is 4 and 12. So basically it's here. 4, 12. What is this? Okay, so actually this question is about understanding. You understand what you actually did for the area part, then you will understand how to answer this question. Okay, so now how to find that? And you should be realized that there is actually like two rectangles. So if you want to find this area, then what you can try to do is, this is a rectangle. You use this rectangle, minus off the curve here, and you minus off this rectangle. So it's basically the big rectangle, right? Your length will be 6, your height will be 12. So meaning 12 times 6. Okay, for the big rectangle. After that, you need to minus off the area under the curve here, which is 30 given by the question. Then minus off this small rectangle, which is 4 and 1. Okay, then you will be getting this answer. So equals to 72 minus 30 minus 4, and you will be getting 38. So 4 to 12 x dy equals to 38. Okay, just like that. So this question is about understanding. Yeah. Okay, so let's look at the very last question before we end. Okay, so given P is the minimum point for the curve Y, the point Q on the curve is such that the gradient for PQ is 2, and you need to find the area of the shaded region. So meaning this is the shaded region, and if you can realize, this is actually the area between a straight line and a curve also. So now maybe we try to write down the coordinate given by the question. So the question gives you that P is actually the minimum point. So minimum point we can read from this equation. So this is in the completing square form already. So meaning this equation will tell you that P is actually 2 and 1. Okay, then we get P. So the point Q is on the curve such that the gradient for PQ is 2. So how can we get Q? So it's basically substitution. So what you can do is you can find out, you can build one equation, or you can build the straight line equation first maybe. Okay, so you have the gradient for PQ is 2. So what we can do is gradient will be equals to y2 minus y1, then x2 minus x1. So your m is 2, and then your y2, the y, you don't know what is that now, minus 1, and then x minus 2. And you will be getting your straight line equation, which is 2x minus 4 equals to y minus 1. So y equals to 2x minus 3. So this is your straight line equation. But how do you find Q? Because if you want to find the area of shaded region, right, you will need what is this value and what is this value. So how can we use this equation to help us to get y? So what you need to do is you have the equation there, then you have this equation, and that is the substitution point. Then you need to do simultaneous equation. So basically meaning this is your first equation, this is your second equation. So 2x minus 3 equals to x minus 2 square plus 1, and continue to solve it. X square minus 4x plus 5 equals to 2x minus 3, and then x square minus 6x plus 8 equals to 0, and you continue that. X minus 4, x minus 2, equals to 0, x equals to 2, 4. So it's correct. You see one of the coordinate is exactly your x coordinate for P. Then how do you get the y? So you know that this is 4 already. Then to get your y, you can substitute back into the equation. So y equals to 2, 4, minus 3, which gives you 5. So meaning your coordinate of Q is basically 4, 5. Okay? Then now you have the value already, which is the 2 here and the 4 here. Then you can try to do your equation already. So try to do your integration. So now we need to find the area of the shaded region. So look at this one. The straight line is above the curve. So straight line is your y1. So differentiate from 2 to 4. And then your straight line equation is 2x minus 3. Okay, then minus for 2 also, the equation of the curve. Can straight away expand that. Dx. Okay, so 2, 4, 2, 4, then you can combine them. Oops, sorry. Okay, so after you get this equation, then now you can substitute them. Do your integration, then substitute them. So substitute 4, substitute 2, try your own. Then after that, you'll be getting 1 over 3. Okay, so that's it for today's lesson, and you should be able to do your exercise 9.6 and 9.7. So for next class on Monday, we will be covering improper integral. Then the last session, which is how to find volume, and we'll finish P1. Okay, so thanks for watching, and I hope that everything goes well for you. So have a good rest. Take care. Bye.